Okay. So, listening please. Today's handout. Transformations. Did we review transformations the first week of school?
Yeah.
Yes. And we talked about doing transformations without patty paper. And some of you freaked out, right? Like, oh, I need my patty paper. I will tell you this. Test day comes, you will be provided everybody with patty paper. And the reason is, not for this one. I'm hoping you can do this one without. But there will be some in the test that we're not going to see today, but we will see this week, where they give you two shapes and they ask you to come up with the rule. Something like this. And so you have to figure how it was rotated. Does that make sense? And it's easier if you do that with patty paper. So that will be provided. So those of you that like patty paper for this type of problem, you can use it for that one as well. But I'm not giving it to you today, so we're going to try without. Which way is clockwise? Turn to the right or turn to the left?
Right. That was left.
Turn it that way.
This is to my right.
Turn it to the right.
Okay, this is like a clock. Yes, tick, 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 right?
Yes.
Okay. All right. 90 degrees. One turn or two? One. All right. So do you guys remember what we did? This is our original 1, 2, 3, 4. You guys remember that's how quadrants are numbered. 1, 2, 3, 4. That's just the way they are.
Yeah.
All right. So when we turn it 90 degrees clockwise, this is my new 1, my new 2, my new 3, and my new 4. All right. And then I'm going to label R prime, S prime, Q prime, and T prime. And I'm going to do that with this being my third quadrant. So for R prime, I'm going to go left how far? 1, 2, 3, 4, and down how far?
5.
So I would write this as -4, -5, because again, this is my new quadrant 3, and quadrant 3 is negative, negative. Do you agree?
Mm-hmm.
Okay, S prime is here. Is that also -4?
Mm-hmm.
Can you guys count how far over or look at your number line?
It's 4. And then it's down
8?
Yeah.
Okay, Q prime would be here, so down,
It's over 9 down
so left 9 would be -9, and down
-3.
-3,
And then it's
-9,
-8.
8. Okay, before I go any further, are there any questions on how I came up with this set of numbers? So again, what was done, I moved it right, it was like this, and I moved it 90 degrees clockwise, and then 1, 2, 3, 4, and anything in quadrant 3 is going to be negative, negative, because you go left and down, left and down, left and down, over and over. So these are all going to be negative, negative. Do you see that?
Mm-hmm.
All right, what do I do next to actually graph the R prime, S prime, Q prime, T? Put it back to its original position, erase these markings that I put in there, and now I plot. R prime is -4, -5, -4, -5, and I label that R prime. S prime is -4, -8, 1, 2, 3, 4, oh, 1, 2, 3, 4, and then down 8, and I'm going to call that S prime. And then Q prime, -9, -3, and I want you guys doing this on your own as well. All right, does everybody see the shape? Okay. Make sense, yes or no?
Mm-hmm.
Any questions? Now, those of you that can you imagine if you did have the patty paper here and you went 90 degrees counterclock or clockwise, it would end up right here? Can you see that? Like those of you that had used the patty paper long enough, can you see where that shift would have ended up being right there? Any of you that felt you weren't comfortable with the patty paper in the beginning, feel like, I can handle it now? Yeah?
What is the equation for this? Like,
What is the equation? Good. It didn't ask us on this particular problem, but could we figure it out? Yes, this is what I would suggest. Look at your R. I'm just going to do R and S because I don't have to do them all. What is this ordered pair for R?
4,
Or 5?
5.
5 and down how far? 4? Is it down 4? 1, 2, 3, 4. And then S is over 8, also down 4. And then look at your R prime. I'm going to write it here. R prime was -4, -5, is that right? And then S prime was -4, -8. So see if you can figure out the rule. Can anybody figure it out? Okay, so 5 to -5. Now the -4 stayed negative, yes or no? And did they switch spots?
Yeah, you just switch spots.
Okay, so 5, so the X goes at the end, and when it goes to the end, does it become opposite? 5, -5, 8, -8. Yes or no? Yep, so -X, and it goes at the end to the Y spot, and the -4 to the -4, and the -4 to the -4, so that is your Y. So Y -X.
Yeah, but there was like an equation he taught us last year, like,
This is it. With rotations, it's just something like this. When you have, like, you're thinking like Y plus 5, Y minus, that's when it's a translation, when you're sliding right and left and up and down. When you're rotating, it's like YX or opposite YX or opposite Y, opposite X, stuff like that. Okay? All right, next one. Yes?
Is it like, she was talking about like something like this, right?
Yes. So is this kind of what you're talking about, Peyton? Thank you.
Yeah.
Yes, so this is for a sliding type problem, which is different from a rotation.
That's a reflective.
This is a translation. To translate, you're moving, you're sliding and rotating. Let me show you guys really quick. This is period 7s, but we can use it. Can you guys see that? So we said the translation was a slide, and that was just sliding, and then there was the reflecting, that you reflected across the axis, and then there was the rotation, which is what we're doing now. And the rotation rules are always like this: opposite X, opposite Y, which you can't see. Opposite X, opposite Y. Okay, so when you see the +3 -4, that's a translation. That's when you're sliding. All right, so let's do that now. Graph the image after applying the transformation. This is the rule. What does this mean? Can anybody tell me what this rule means?
You go, say you go left 1 or like -8.
So you go left.
Take your point,
Mm-hmm.
left 8 points,
Okay, and then we'll go up.
and then you go up 4.
Up 4. Pause before, if you're working, please just pause. How many of you guys are doing that already? Just sliding. Left 8, up 4. Now, we talked about another way when we first talked about this that first week of school. If you had ordered pairs, we don't have them here, but if we had them listed, could we just apply the rule? Subtract 8 from the X, add 4 to the Y, and then plot the new set of points? Yeah, but is it easier in this case to just slide, like you said, left 8, up 4? Yeah. All right, so go ahead and do that now, if you haven't started it already. And try it on your own. Shouldn't even be looking at mine. I'm just doing mine so that when you're done you can look up and check, but for now you're doing it on your own. All right, everybody done? When you're done, will you double check it with mine? Does it look the same? Yes? Not yet. Okay, so right now we're just sliding. What's the second step ask us to do? Reflect over the x-axis. Okay, now I already called these primes, so I'm just going to erase the primes. That was just keeping track of them. When I flip them is when I'm actually, you know what? I'm going to put these back. Did you guys do this last year? If you did more than one transformation, what would you call it on the next one?
Oh, prime or
Double prime.
double prime.
Yes, okay. No, it's okay. All right. Now, guys, this one is a lot of work, so I do need you listening. It's not hard, it's just tedious. Do you agree? Okay, so how do we reflect across the x-axis? For this point N that goes up 1 from the x-axis, I'm going to go down 1. And I'm going to call this N double prime. I'm tempted to use a different color. I just don't like working in pen on graph paper because if I make a mistake. All right, N prime, and it's going to get really messy really fast. All right, if P is at the origin and I'm reflecting, what's going to happen? Is it going to stay there? If I have a point at the origin, I'm reflecting either x-axis or y-axis, it's going to stay. All right, I'm going to do Q. Q went down 1, 2, 3, 4, 5 from the -2. So instead of going down 5, I'm going up. 1, 2, 3, 4, 5, and I'm going to call that Q double prime. And then what's my last one? Is it the M? 1, 2, 3 down, so I'm going to go 1, 2, 3 up. Ugh, looks messy. All right, do you guys have that? I'm going to use a straight edge or piece of paper only because I'm working in pen. All right, now I'm doing this one with you. I'm hoping you were working on your own and just looking up when needed. Could you handle something like this on your own?
Yes.
No? Did your guys' come out different? Kind of hard to see.
It's the blue one?
Yes, the blue one is the final one.
It's gonna be gross.
Okay. Yes, are we good? Now, it takes a while, but was it really hard? No. All right, any questions? Next one. Take a look. And it says, and I want you to do this on your own, describe in words the transformation used to create STU. Include the coordinate notation rule in your answer. Now, I did mess up on this copy. Can anybody tell me what it was?
You said,
Yes. There's no letters. You are correct. What the heck is STU? We don't know because there's no letters. So I will call this A, B, not S, C, and STU. And the question is, what was done? Describe in words. Don't blurt it out. Describe in words the transformation used to create this triangle. So what was done to this triangle to get to this triangle? Don't write it down in words. You're writing it down here. All right. Now, is this an easier one to look at and see what it is? Yeah. Which ones are the harder ones? The rotations? And sometimes even the slides, the translations, you're like trying, is it down, is it right, is it up, and looking, but what type is this?
Transformation.
It is a transformation, it's a reflection. The reflections are typically a little easier. Sometimes they might throw a reflection and a translation, then it gets a little harder. All right, a volunteer, hand up to tell me what it is in your own words. I saw a few hands up earlier. Yes, right here.
Reflect across the y-axis.
Okay. reflect across the y-axis. Identify the congruent angles of the triangle shown. Okay, so angle A is congruent to angle S. Angle B is congruent to angle T, and the last one, angle C, is congruent to angle U. What are those called? It starts with the C, not just congruent angles, but C. I heard it. What is it? Corresponding. They're corresponding angles. Now, does this reflection preserve rigid motion? Is it a rigid motion? Yes, and that there'll be that type of question on the test. What does rigid motion preserve? The size and the shape. You are correct, and you need to know that because you need to put that in words. There'll be a blank line. Is it rigid motion? Yes or no? Explain why. And you have to say in your words. Preserves the size and the shape. All right, questions here.
Wait, can you scoot it over just a little?
Yeah. Okay, congruent sides. I'm going to do AB. AB, and I'm going to call on Sophia. What is AB congruent to? What side? To ST. Thank you. And then I'm going to do BC. And I'm going to call on David. What is BC congruent to? TU. Good job. I have AB, BC, and I'm going to do AC last. And I'm going to call on Cole. What is AC congruent to? What side? SU. Yes?
Yeah.
Okay. Any questions? We're good? Okay, let's flip this over to the back side. Funny, funny.
You looked at him like, really?
All right. All right. No.
That was great. That was gold.
Guys, number 4. Should I put it right here next time really big? I flipped it over and he asked, is the back homework? Because there's no...
Should put homework on the front to freak people out.
All right, number 4. Triangle ABC has the coordinates blah, blah, blah. Reflect ABC over the y-axis, then translate right 4. Label the image A prime, B prime, C prime. All right, I'm going to have you plot ABC first on your own. Okay, go ahead and do that first. ABC. All right, yes or no on your ABC?
What?
Yep.
No? Yes. Yes, just make sure you sign out. All right,
Wait.
what?
I didn't even come close to getting that.
A is 4, 1, so you go over 1, 2, 3, 1, 2,
Oh, I
3,
heard.
4, up 1. And then 1, 3, I go over 1, up 3. And then did you flip them around?
Yes.
C is over 2, down 3. So hopefully you're not working in pen. All right, so if you didn't have this shape, double check it, fix it. All right. Now, they're asking us to do what first, and it does matter. They're asking us to do what first? Reflect over the y-axis. This is the y-axis. So I'm going to be reflecting right and left. Do you see that? Okay, so point B goes 1 to the right, so it's going to go 1 to the left. Now, I don't want to call it B prime only because they want me to call my final answer A prime, B prime, C prime. So you can do something like this, B with the squiggle or B with the star. or B with the double prime. It's up to you, as long as you don't call it B prime. I'll just put a double one there for now. All right. A from the 1 goes 1, 2, 3, 4. So other direction, 1, 2, 3, 4. And that is the A prime. Oh, double prime. And C from the -3 is right 2. So I'm going to go left 2 and call that C double prime. All right. And then connect. I'm going to do this one just a little lighter so it doesn't get too messy. Okay. Does that look like a reflection across the y-axis?
Yes.
Yes? All right. What's the next piece? Translate right 4 and up and down, or just right 4?
Right.
Right 4. Okay. So what are we going to do? We take each point, and I'm going to change colors only because it's going to get messy. And 1, 2, 3, 4. Does C end up back in its spot?
Yeah.
Okay, C prime. How about B? 1, 2, 3, 4. Does that one? No. This one is B prime. And A, 1, 2, 3, 4. This one is A prime. Okay, so do you see my A went over, that's A prime, my B went over, that's B prime, and then my C went over, that's C prime. I know it's really messy, but then connect. And I will have straight edges for you if you need them on the test, so they're not coming out too sloppy. And of course the patty paper. When is our test day? Friday. Oh, is it Friday? No. Quiz. Quiz is this Friday. You scared me. When is our test day?
Wednesday.
Next week on block day. All right. Everybody have it?
Oh, I thought I had it just on my birthday.
When's your birthday?
Tomorrow.
Oh. Happy early birthday. Okay, everybody get it? Yes or no? Yes. Okay. Questions before we move on? All right. Do this one. Rotate XYZ 180 counterclockwise. Before you start labeling, at least get your position. 180 is how many turns? 2. Counter to the right or to the left?
Doesn't matter.
Why does it not matter on 180?
It's 2 turns.
2 turns. 1, 2 would be the same as 1, 2. Yes or no? But we should still know the difference. So which direction is counterclockwise?
Left.
1,
Wait,
2.
no.
Yeah? Because clock is tick, 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 tick like this, so counter would go the other way.
Can we just reflect it now?
Let's see. Well, it does say rotate, not reflect. The one up here I've reflected and translated.
Oh, yeah, you learned on my arm.
Okay.
Yeah,
So, guys, 1, 2. Now these are the ones where I like to write sideways. Why do I write sideways like this, all crazy?
So that you can see it when you flip it.
Right, so when I flip it back, I'm not trying to read upside down. I mean, I'm sure you can read upside down. Okay, so 1, 2, 3. If this is my new quadrant 3, this point X is 0, 1, 2, 3. So what is that? 0, -3. This Y is -1, 2, 3, 4, -5. Down how far? Can you guys count it?
5.
Down 5. And the Z is -1, 2, 3. Down how far? 2. All right. Any question on how we got X prime, Y prime, Z prime? All right. Flip it back over. What do we do with these points? Plot them, graph them. 0, -3. That is the X prime. negative 5, negative 5. That is the y prime. And negative 3, negative 2. That is the z prime. No? All right. We're going to be running out of time soon, but I want to at least go over how to find the slope again. If I'm looking for the slope of x, y, what do we measure? Rise over run, and we went over a big deal about positive over a positive or a positive over a negative. Do you remember that? Okay, so I rise 2 in the positive direction, and I run in the positive direction. How far do I run? 5. So what's my slope? 2 over 5. Slope of x prime, y prime is here. Count it. Up 2 over how far? 1, 2, 3, 4, 5. If I go up and right, is it still positive slope? Yes or no? Yes. How are these slopes related? What does it mean if you have two slopes that are the same? The lines are what? Is that you saying it? You're right, yes. She's saying the lines are parallel. I couldn't tell where it was coming from. These two lines are parallel, so you can write that down. If they're only parallel, the slopes come out to be the same. All right, that doesn't mean it's going to happen tonight, so you have to address whatever you get tonight. What worksheet are you doing tonight?
B, A, 3.8.
3.8A. Is it in your packet?
Yeah.